Let's go through this Mathlinks 8 1.1 assignment. What is the prime factorization of 920? We want to break it down to get the prime factorization. So when you look at the 0 here, you know that 10 times something becomes 920 is going to be the 92. 10 can be broken down to 2 times 5. Whenever the 92 has an even last digit, you know that you can factor out a 2. 2 times what is 92? You can try having that. 46 plus 46 indeed is 92. 46 again has an even last digit, can be broken down with 2 again, and 23. 23 is a prime number, which means it can't be broken down any further, so we're done. You circle all these prime numbers, and that's your prime factorization. The prime factorization is 2 times 2 times 2, or 2 cubed, times 5 times 23. So dots is also means multiplication. This is the prime factorization. Just for your information, the prime factors, which is part B, is going to be the bases. The bases 2, 5, and 23. Let's solve. X plus 2 equals 7. X is an unknown variable. It stores a number. It represents a number, a mystery number. What plus 2 is 7? You have 7 puppies. You know you have two puppies. 2 puppies plus what is 7 puppies? It's going to be 5 puppies. So X is 5. Another way of doing this algebraically is to throw this positive 2 over. The positive 2, when you throw over the equal sign, becomes a negative 2. The signs flip when you throw things over. You can also think of it as subtracting 2 from both sides, and that's fair. So the answer is X is 5. Whoops, we skipped number 2. Let's go back up to number 2 here. What is the perimeter? The perimeter is basically you're an ant walking all the way around, and these are the same, so this is 5 plus 5, and this is 3 plus 3. Add them all up, this is going to be 16 meters. And the area is going to be this times this. For rectangles, just memorize that. 3 times 5 is 15 meters squared. So area is always units squared, whereas perimeter and length is always just the unit. Number 4. What number is between 4 and 20? The fastest way to do these types of problems is to think number line. 20 is here, 4 is here, you add them. 20 plus 4 would be 24, and then you divide by 2, which would be 12. So what we're saying is that the halfway point is going to be 12. And you can test this theory out by thinking, what's the difference between 12 and 4? You know that this is going to be 8 apart. And then you can see here that this is also 8 apart. So add the numbers and divide by 2. List the first 4 perfect squares. So 1 is a perfect square, because 1 times 1 is 1. 4 is a perfect square, because 2 times 2 is 4. 9 is a perfect square, because 3 times 3 is 9. And the 16 is a perfect square, because 4 times 4 is 16. 25 would be the next perfect square. 10 is not a perfect square, because what times what is 10? You can't do that. These are perfect squares. They're square rootable, and you get a nice integer when you do so. Is 1000 a perfect square? No. Because 10 times 10 is equals to 100. So you would say 100 is a perfect square. But what times what's 1000? You can't do that. What if you say what's 100 times 100? There's going to be 4 zeros here. So the answer is going to be the number 1 with 4 zeros, which is 10,000. So 10,000 is a perfect square. But when it comes to 1000, it's not. No. The square root of 30 is between what 2 integers? 5 times 5 is 25, which is too low. We're trying to aim for the number inside here. 6 times 6 is too high. It's going to be 36. So therefore, this square root of 30 is between 5 and 6. These are the integers. Place root 20 on a number line. You know that 4 times 4 is 16, so that's too low. 5 times 5 is 25. That's too big. It's bigger than this number here. So therefore, the square root of 20 is somewhere between here. Number 9. We have this nice rectangle. 40 times 10 is 400 centimeters squared. Now we want to have the same area as a square. So if the area here of a square is 400 centimeters squared, what times what is 400? But this is a square, so it has to be the same dimensions. And the answer is 20 times 20. So the dimensions are 20 by 20. Now here's a nice 49 meters squared area of a square. The side length is going to be the square root of that, which is 7. If this is 7, 7, 7, 7, the perimeter, you add them up, is going to be 7 times 4 is 28 meters. This is good to memorize. No calculator. Wow. What times what is 289? That's pretty overwhelming for most students. But just practice memorizing the times tables. Or just you can guess and check. 10 times 10 is 100. Too low. The goal is to get the inside. 11 times 11 is 121. Too low. And you keep on going. Hopefully you memorize these, but otherwise you have to work them out by trial and error. 15 times 15 is 225. Still too low. 16 times 16 is 256. It's still too low. And then 17 times 17 is 289. So this answer is actually wrong. The answer should be 17. So good thing we went over this video solution. So there's your answer. It should be 17. By the way, just for information, 18 times 18 is 324. And 19 times 19 is 361, and then 20 times 20 is going to be 400. So these times tables up to 20 times 20 is so famous because usually the numbers on the test are quite low unless you have a calculator. Okay, what's the square root of this huge number here? 300 times 300. 3 times 3 is 9, yes, and we have 2 zeros and then we have another 2 zeros, so indeed this looks right. So I'm going to put a star here because number 11 we needed to correct. Number 13, the answer is 2/3 because you take the square root of the top and bottom. Square root of 4 is 2, square root of 9 is 3. And when you have something like this, fractions squared, this is the same thing as 2/3 times 2/3, and you multiply across. When you're multiplying fractions, it's actually easier than adding fractions. You simply multiply across. 2 times 2 is 4, 3 times 3 is 9. Another way of thinking about this is you can distribute the exponent to the top and the bottom. You learn more about exponent laws next year. But this is going to be 2 squared over 3 squared, which is 4 over 9. The last question here is, use prime factorization to find the square root of 900. So some students might guess the answer is 30. 30 times 30 is 90, and that is going to be root 900. That's great. But that's not what the question is asking. The question is to use prime factorization, this tree, to actually help you find the square root. So let's not focus on the square root, let's just focus on the number. The number is 900. So what we have here is 900 breaks down to a tree like we did previously. And it breaks down to 2 times 2 times 3 times 3 times 5 times 5. Now the whole idea of square root is what times what becomes the inside. So therefore the answer is going to be 2 times 3 times 5. For every pair of numbers, think of it like 2 people in jail breaking out of jail, and there's your answer. So for every 2 people that try to break out of jail, only 1 person survives, and the other person disappears. So you can see that we use prime factorization. You can see the pairs quite quickly. 2 times 3 times 5 is the answer. And so the answer of the square root of 900 is going to be 6 times 5, which is 30. Great job.